Lesson 2.5 is about statistics, and it's about displaying and analyzing data. We're going to talk about line plots, we're going to talk about stem and leaf plots, and we're also going to talk about the mean, median, and mode, which are also called measures of central tendency. So for measures of central tendency, the first thing we'll go over is the mean. The mean is the sum of the numbers in a set of data divided by the number of items. So if our set of data would be 2, 4, 7, 8, okay, then we would simply add 2, 4, 7, and 8, and then divide that by 4, because there are 4 items in the data set. So in this particular case, we'd get 6 plus 7 is 13, 13 plus 8 is 21 over 4, and if we put that into our calculator, 21 divided by 4 would be 5.25. So that's the mean. The median is the middle number in a set of data when the data is arranged in numerical order. If there's an even number of items, then the median is the mean of the two middle numbers. So if we look at our same example, the data set of 2, 4, 7, and 8, that's already arranged in numerical order. If it wasn't, we would have to do that first. Then what we'll do is we'll look at the two middle numbers, because there isn't one single middle number. So when there's an even number of items, and if it's a long list, what I would suggest is that you just kind of cross off numbers from the ends until you can find the middle number or numbers, whatever the case may be. And then when you find the two in the middle, you add those together and take the mean of those two. So 4 plus 7 is 11 divided by 2, so that would be 5.5. And lastly, for measures of central tendency, we have the mode, which is the most frequently occurring number or numbers in the data set. In the case of our previous example with 2, 4, 7, and 8, we have no number that occurs any more frequently than any of the rest. So in this case, we would say no mode. But it is possible that you might have a data set where there are repeating numbers, and whatever is the most frequently occurring is the mode. So let's just do another example, just so we're sure we understand. If we had 2, 3, 3, 5, 6, 7, 7, and 8, okay, in this case we would actually have two modes, because we have our 2 3s and our 2 7s, and they occur with the same frequency. So 3 and 7 would be our mode in this particular example. Okay, so now we're done with talking about measures of central tendency. Now we're going to talk about stem and leaf plots and line plots. We'll start with line plots because that's by far the simplest. So a line plot really looks a lot like a number line, and all you really need to do is plot your values in your data set along the number line. It's a little bit different though. Normally when we do a number line, we just put a dot on the number line where that particular number is. However, sometimes in a data set we have more than one of the same value. And because of that, it wouldn't make sense to just keep putting dots on top of dots. So we're going to use X's instead. So let's take a look at a particular example. If we have a set of data, and this is actually from a university basketball team, and we look at the height in inches of the members of the team, we have someone who's 74 inches tall, we have 72, we have 76, 78, 81, 75, 79, 80, 79, 83, 77, 76, 79, 72. Okay, so what we'll do is we'll just put X's and we'll start crossing these off as we put an X on the line plot. So 74, we'll put an X right above 74. 72 would go here, 76 here, 78 there, 81 there, 75 there, 79 right there, 80 right there, another 79. So when we have another one, we just kind of stack the X's on top of one another. 83, I didn't make my line plot large enough, so we'll skip that one for now. 77, another 76, and another 79, and another 72. Okay, so we just stack those X's up as many times as we have values of, that particular number. So that's how you do a line plot. Another way to organize data is a stem and leaf plot, and the way we do that is we just look at the greatest common place value of the numbers in our data set, and that's used for the stems, and the numbers in the next greatest place value are used to form the leaves. So in the case of the height of the basketball team members, they all started with either a 7 or an 8, okay? So we'll have a stem, and then we'll have our leaf over here. So we'll have 7 and 8 for our stems because all of those heights started with either 7 or 8. And then we'll just add in the second digit for the leaf. So there was a 74, so I'll put a 4 there. There was a 78, and there was another 78, and there was another 78, and then there was a 79, and so on. There was let's see, there was an 81 and an 83, and I think that might have been the highest, I'm not sure. But in any case, okay, so the values here really are 74, 78, 78, 78, 79, 81, and 83, but we simply display it in a little bit different way. And it kind of allows you to see, I mean, this is a really easy way to tell what the mode is, because when I see these 3 8s right here, I go, okay, well, my mode is certainly would equal 78. And so sometimes for some types of data or measures of central tendency, it's a little bit easier to tell from a stem and leaf plot than it is from a line plot even. But those are the 2 types of plots that we'll be working with, and the 3 measures of central tendency. So that's about it for today.